Hi guys. Okay, so last time we kind of talked about why electrons are able to move in the way that they are, and that's because of their relative size. So let's talk a little bit more about the rules of charges today in this lesson, and then we can go kind of from there. So we're going to be talking about how an object overall can have a charge. So if this is my object here, how can it have a net positive charge if it begins with being neutral? And how can it have a net negative charge if it begins with neutral as well? So remember that last time we talked about positive charges are going to stay in their places. We're really going to be looking at negative electrons because they're smaller and they're more easily movable. Then if they move away from a certain body, they're going to be leaving that object with a positive charge because there's a deficit of electrons. And then in terms of gaining electrons, that body is going to be left with a net negative charge because there's more electrons than there are protons in that object. So let's take a look at what the rule of charges say. Now, the rule of charges is a really big kind of like rule in electrostatics because it basically governs the way that we look at things and how matter behaves with each other. So the rule of charge has three properties within it. And the first one is that there's only two types of electric charges, and we kind of dissected that in the first little bit here. Neutrons are not considered charges. Neutrals are not considered charges because they don't have that net. So the first charge is positive and the second charge is negative. And those are basically dictated by the electrons moving in and out of the system. This second law is basically that like charges repel each other. So, for example, if this was a positive charge, these both would be accelerating away from each other with a certain amount of force, which we'll get into next. So, in between them, at the center of their masses, they're going to have a force that's going to be repelling. And then, if we think about it in terms of if this was a negative charge, if they were different, then oppositely, unlike charges are going to attract each other. So each one of these is going to move towards each other and accelerate towards each other's centers. There's another law as well. It's called the law of conservation of charge. And this one is basically like every other conservation law there is in terms of thermal energy, in terms of kinetic energy, potential energy, mass, anything. It's basically the same, and it basically just says that electric charge can't be created or destroyed, but only transferred. So if a net charge on a system was zero, then after everything that's been done to it, that charge is still going to be zero on that system, no matter what electrons were transferred for what body. And then another thing that we should probably touch on is how can these objects even become charged? How do they get these different types of electrons moving into each system? So there's three different processes that allow for that to happen. The first one is friction, the second one is conduction, and the third one is induction. And we're going to be talking about each one. So in terms of charging by friction, what we're going to be seeing is rubbing and a input of energy so that electrons can make a jump. Basically, what's going to be happening is that certain bodies are going to be either insulators or conductors, and most likely, if there are two objects that are conductors, they aren't going to be able to transfer electrons without a little bit of added energy. So unless you actually rub two objects together and put that energy in, they're not going to be able to make electrons move to each body. So let's say that I have an ebonite rod, for example, this, and we charge it with some wool. So I'm going to rub it, friction, and when it's rubbed, some of the electrons from this fur are going to be captured by the atoms in this ebonite, and we call that electronegativity in chemistry because the electrons are more strongly pulled by the ebonite rod. And it's a known fact that when ebonite is rubbed with fur, the fur is